Today we learn Benzoin condensation. Benzoin condensation is an self-condensation reaction of aromatic aldehyde with no alpha hydrogen atom in presence of potassium cyanide to give alpha hydroxyketone is known as benzoin condensation. That is self-condensation of of aromatic aldehyde with no alpha hydrogen atom in the presence of potassium cyanide, cation or anition to give alpha hydroxyketone, which is also known as a benzoin, and this reaction is known as a benzoin condensation. Okay, now we'll see the particular example, that is aromatic aldehyde, that is an benzaldehyde, is treated with cation, that is the two molecules of aromatic aldehyde benzaldehyde in presence of cation and ethanol gives rise to alpha hydroxyketone. Here it is CHOH and then second carbon C double bond O. This is an alpha hydroxyketone. Out of two functional group, this is a principal functional group, and this carbon is an alpha carbon. Hence, it is known as alpha hydroxyketone, which is commonly known as benzoin condensation. Now, see here, what is the basic requirement? The aromatic aldehyde without alpha hydrogen atom means take such aromatic aldehyde which doesn't contain the alpha hydrogen atom in presence of cyanide ion. It gives rise to alpha hydroxyketone. Now, this reaction can be done with the substrate present on the aromatic ring. Okay. Now, we will see the mechanism why cation is used in this reaction. Mechanism part is very important. Initially, what happens, whatever the potassium cyanide is present, that undergoes a dissociation cation to gives rise to K plus Cn minus ion. That Cn minus ion will be attacked on the carbonyl carbon of aromatic aldehyde CHO plus here the Cn minus. Here it undergoes the nucleophilic addition type of reaction. The pi electrons will be shifted towards the oxygen. It becomes O minus. Now it becomes here C, O minus HCN. Now here it is very interesting. Here what happens? The Cn minus immediately withdraws the electron from carbon. Okay, indirectly that carbon withdraws the electron from hydrogen, and that proton will be attracted by the O minus, and the negative charge will be generated on the carbon. Here CH, driving force in the reaction is the Cn, which is electron withdrawing group. Now what happens? This negative charge obstructs the proton due to electron withdrawing nature of the Cn, and once that carbon ion is generated, that will be stabilized by the electron withdrawing group. It is OH, this is Cn, now this is an carbon ion. Very interesting. Here the carbon is generated. Two important reasons. One is the CN withdraws the electron from carbon and that's why it becomes acidic. Secondly, whatever the negative charge generated on that carbon, that will be stabilized by the cyanide, that is C triple bond N, which is conjugated with the negative charge. For as you will see how that resonance takes place, I will show here how the resonance takes place. No doubt there is a resonance of the double bond present in the ring, but the extra conjugation is of the cyanide C triple bond N, and this is the negative charge. Now what happens here? This is the resonance. This negative charge is conjugated with the triple bond, hence negative charge form here double bond, and this is shifted on the nitrogen. In this way, the resonance takes place, and that negative charge, that is the carbon, gets stabilized. OH double bond Cn minus. In this way, that carbon gets stabilized. This is the resonance. That is the one of the reason. Then we will see the further next step. Once that carbon gets the negative charge, that will be attacked on the second molecule of the aromatic aldehyde, that is the benzaldehyde. We have the two aromatic aldehyde. Out of here the second aromatic aldehyde CHO plus whatever the carbon generated here as COH, here the Cn, and that carbon having the negative charge, that is the carbon. Now what happens here? That carbon, the negative charge will be attacked on the carbon carrying, that is oxygen, which facilitate the reaction, that is nucleophilic addition, and the oxygen will withdraw the electron. Now it becomes, you can write here C O minus H. Okay, here C, here Cn, and this is the OH. Now in the next step, what happens? The OH, again here this OH bond becomes more acidic. One reason is that already the oxygen is electronegative atom. Further, that acidity is increased by the electron withdrawing group Cn. Hence, that H plus will be dissociated and that will be abstracted by this negative charge. Okay, it will take the proton. It will take the proton and charge will be shifted on this oxygen. Then in third step, next step whatever, now it becomes, this is COH. Now this becomes OH group. This is H, C, Cn, and this is the O minus, and this is N. Now what happens? This negative charge form here double bond, and the Cn is good leaving group that leaves this position and form here double bond. In this way, we will get the product as here C OH EH, here C double bond O, and this is an alpha hydroxy ketone. This is an functional group. This is an alpha carbon alpha hydroxy ketone. This is our target molecule. In this way, simple mechanism. Remember the first step, that is the dissociation of cation. Once cation undergoes the dissociation, that in further step the Cn minus will be attacked on the carbon of one of the aromatic aldehyde. Then what happens? That Cn withdraws the electron from the carbon and the proton will be abstracted by the O minus, that carbon, and it generates the carbon, and that carbon is stabilized by the Cn ion. Then the carbon generated in that step will be attacked on the carbonyl carbon of the another aromatic aldehyde, Then we'll get the oxide ion. That oxide ion abstract further proton from the OH group. Okay, and then finally here that oxide ion abstract the proton, which is more acidic. Once it abstract the proton, then negative charge here, it form the double bond and there will be loss of Cn minus, which is a good leaving group. The question is that why we are using the cation, why we are not using another like KOH, NOH. The reason is that the question will be asked in this, that is why the cation is used in this reaction. The main thing or main points for this one is, first one, cation is an, that is Cn minus, is a good nucleophile, as we seen in the first step, it will attack on the carbonyl carbon. Secondly, Cn minus stabilizes carbanion, and third step, Cn minus is a good nucleophile, Cn minus stabilizes the carbanion, and the last one, Cn minus is a good leaving group. Due to these three reasons, the cation is used in this reaction. Okay, we'll stop here.